Hi everyone, today I'm going to share my experience in creating a simple data pipeline for chatbot message logs. Before we begin, let me introduce myself. I'm Dewi Octaviani. I got my master's degree from Waseda University on 2017 and currently I'm working as data engineer in Kata.ai. In a day-to-day, I'm doing ETL and creating data pipeline for millions of conversation logs behind chatbot and make sure the data is qualified enough to be processed by other teams such as data scientists, business analysts, and so on. You can find my portfolio in my GitHub account and feel free to connect with me on my LinkedIn. Let's go to the introduction part. This is what Kata.ai do. So what we do is to provide a web platform for you to create and manage bots easily. This is the Kata platform where you can just drag and drop diagrams, fill the parameters and train conversations that you want bot to understand in this platform. And if you want to test your bot, you can just try it on this bot web emulator. Once your bot is ready, you can deploy your bot to multiple channels that are available in our platform without worrying the API. And your customer now can connect with your bot. It's very easy to build a bot. As we are growing up, we handle more and more clients. And of course, millions of conversation logs are coming every day. Yes, we need a scalable data pipeline. This is the schema that describes how conversations happens between you and bot in our platform. Let's see on the diagram. First, we have incoming message from WhatsApp or other messaging channels. The message is sent to webhook service and then consumed by message broker. The message broker delivers message to dialog engine service. In this service, we chunk down the message, predict intent, and choose the predefined reply message based on intent, and then send back to message broker. Now the problem. We need a scalable data pipeline. In current implementation, we use RabbitMQ as message broker. Why? Because we need to guarantee messages between services are delivered orderly by time, because RabbitMQ can requeue messages whenever services are unreachable. But there are problems with RabbitMQ. RabbitMQ cannot persist messages. All messages are gone to the consumer. Hence, we want to keep messages. Why? As the company keeps growing, more teams need to be able to access message logs, such as business team needs to analyze characteristics of bot, and data science team need to retrain the dialog engine service. And then here, we as the data team should make sure the availability of data. But current architecture does not support it. That's why we need to scalable the data pipeline. In this part, we will explain the solution to our problem. We take a look on Apache Kafka. Apache Kafka is a distributed event streaming platform that's capable of handling trillions of events a day. This platform can be a messaging log, where we can persist all messages on the disk. Kafka Streams API is also powerful that allows you to aggregate, perform joins of data within a stream. So how do we implement Kafka on our architecture? Should we drop RabbitMQ and change to Kafka at all? No. Change RabbitMQ to Apache Kafka at all is not easy because we need more effort to adjust implementation on attached services. So we adopt hybrid solution to solve our problem. We will use Apache Kafka along with RabbitMQ. We just need to add behaviors on webhook service to publish to multiple message brokers, and the data published to Kafka will be processed further in analytics service. In the implementation part, I will show you the simplest data pipeline process that maybe later you can try in your local computer. This is our scenario. First, we will publish message from service to Kafka in your local computer. Then, we will create script in Python to stream data from Kafka to Parquet files. And then, we can do ETL process on files via Jupyter. How does Kafka work? So, first of all, Kafka receives messages from publisher, and then Kafka stores data on each topic. Then the other service can subscribe from Kafka topic. The Kafka will provide message to those services without deleting its messages. Okay, to implement this, first thing first, we need to set up local Kafka in our computer. And then we should run Zookeeper and Kafka service using this command. And then we should create Kafka topic with this command. Okay, what is Zookeeper actually? Zookeeper is a key value store that is used to maintain Kafka. Kafka needs Zookeeper in order to run. So we need to run Zookeeper instance first before we run Kafka. And then let's make a simple publisher script in whatever. You can use Node.js, Python, Golang, or anything to publish messages to Kafka topic. Then let's go to this part. Let's create a Python script with PySpark to read messages from Kafka and write to file storage in a Parquet format. What is Parquet format? Parquet is an open source file format available to any project in the Hadoop ecosystem. Parquet stores binary data in an efficient and flat columnar storage format so that Parquet can reduce cost for storage. And also Apache Parquet file works best with the server's technology such as AWS and GCP. Here is the code. In the first part, we read stream messages from Kafka topic, and then we extract certain values that we need to process. We need date. Here we need date column to identify the time of these messages. And the last part is the writing part, which will write our data stream to a file storage in Parquet format. These are the generated Parquet files on folder Parquet. Either way, you can use cloud storage such as AWS or GCP to store Parquet files. Once the data is stored on Parquet files, we can do exploratory data analysis to get insight about it. We will use Jupyter to do this because it is easier to transform data with pandas or other library supported in Python. In this exploratory analysis, we can obtain how many times in a day the bot didn't reply messages from customer and average response time for message processing. Those informations are valuable for business team to get insight of our bot service. Okay, about the conclusion. Based on our experiments, we can conclude that changing the behavior of a large system cannot be straightforward. And then Spark is a powerful tool to build data pipeline, and Kafka is good for message logging. And the third, a scalable data pipeline can help business analyst teams get insight just in time. And last, there is no silver bullet to a problem. Each tool has different characteristics, so make sure the tools are scalable. This is the last part of our presentation. Thank you for your attention.